In this lecture, we're going to look at chemical bonds. So by definition, a chemical bond is some attraction or force between two atoms holding them together. We're going to learn three types of bonds: ionic bonds, covalent bonds, and hydrogen bonds. What I want you to pay particular attention to is how strong the attraction is. Some bonds are stronger, some bonds are weaker, and how that bond forms. So let's look at the first one. The first one is called an ionic bond. An ionic bond is formed between ions. So let's first talk a little bit about what an ion is. An ion is when an atom either gains or loses an electron. If an atom loses an electron is negative. When you lose a negative, you become positively charged. So atoms that lose electrons are positively charged cations. The opposite would be if you gained an electron. If you gain a negatively charged electron, you're an anion, which is a negatively charged ion. When this happens, opposites attract. Cations and anions will form ionic bonds. So by definition, an ionic bond is formed by atoms after they have gained or lost electrons. They are relatively strong compared to, say, a hydrogen bond. They are not as strong as a covalent bond. So as far as strength, covalent is the strongest, ionic, then hydrogen. In fact, covalent bonds usually require an enzyme to break them. If you were to put sodium chloride in water, just the presence of the water will break the ionic bond. And we'll look at that in a moment. So the perfect example is sodium chloride. It's one that's used by every book to explain what an ionic bond is. There are a lot of other atoms that form ionic bonds, like calcium chloride, calcium phosphate. But as we see here, here's an atom of sodium, or Na. It has lost an electron and become a positively charged sodium cation. Here is chlorine. It accepted a negative charged electron and became negatively charged anion. Now, the question is why? It goes back to those orbits, those electron orbits. They like to have a certain number of electrons in the outer shell. And notice that this sodium now has nice pairs of electrons in that outer shell. Before that, when it had that electron, it had one lonely electron sitting in that outer shell. That atom doesn't like that. So to make it easier, to make it, I like to call, a happy atom, it gets rid of that electron so it has these paired up electrons in the outer shell. Same thing is true for this chloride. This chloride would love to have one more electron because then it pairs them all up in that outer shell. So it gains an electron to pair up those electrons. And here's what happens. The opposite charged ions attract to one another, and that forms a bond or an attraction between those two atoms. When there's very little water, it forms crystals. We know that. We put this stuff on our food. This is salt. And they form this crystalline structure. You put this in water, and the water breaks the ionic bonds and dissolves the sodium and chloride. So those are ionic bonds. The next one are covalent bonds. The key here is they share electrons. It's not gaining and donating electrons in attraction. It's sharing of electrons. And the same kind of principle in that it makes that outer shell happier. So what happens is we have certain atoms love to form covalent bonds. The two most common in organic molecules is carbon and hydrogen. Carbon has these 4 electrons in its outer shell. It wants to have 8. So what it often will do is share pairs of electrons with hydrogen. So what happens is these hydrogens each have one electron in the outer shell, or the only shell. It would like to have two, so it's going to share pairs of electrons with carbon. And when carbon forms covalent bonds with four hydrogens, that molecule is known as methane, or CH4. Oxygen and hydrogen like to form covalent bonds. We call that water, H2O. So if we go back up here, one pair of shared electrons is called a covalent bond. Carbon bonds with hydrogen to form organic molecules. So by definition, an organic molecule has carbon and hydrogen. Other compounds are inorganic. If we go back to that sodium chloride, that's inorganic. It doesn't have carbon and hydrogen. And inorganic molecules typically like to form ionic bonds within them. One other point to make. There sometimes is unequal sharing of electrons. So notice in this water molecule, we have what's called a partial positive charge at the hydrogens and a partial negative charge at the oxygen. What happens is it's unequal sharing. This oxygen likes to hold those electrons more often and closer to it than the hydrogens. So it pulls the electrons towards that oxygen, making it slightly negatively charged. If you look at methane, it's equal sharing. When it's equal sharing, there's no partial charges that exist. We're going to talk more about this, but when you have this partial positive and partial negative, we call that polarity. Water is a polar molecule. It's polar because it has opposite charges at different areas within the molecule. Methane is nonpolar. It doesn't have any of these partial charges within the molecule. So that's a covalent bond. Here's where we actually discuss this idea of polarity a little more. Covalent bonds can be nonpolar or polar. Nonpolar is equal sharing of electrons, no partial charges. We saw that with methane. Lipids form a lot of nonpolar bonds. If you are polar, there is unequal sharing of electrons. Partial charges exist within the molecule, and you always see this partial charge designated at different points in the molecule. What happens then is these molecules can attract to one another. Water is attracted to other water molecules because the partial positive charge attracts to the partial negative charge of another molecule. And what happens is when we have molecules, polar molecules, like water, that attract to other polar molecules, they form a bond called a hydrogen bond. So you can imagine that if we had another water molecule, the oxygen atom would be attracted to this hydrogen atom, and that's called a hydrogen bond. So here's where we discuss this, and this drawing will help show how these hydrogen bonds form. Hydrogen bonds are the weakest. So covalent on the previous slide, those are the strongest chemical bonds we're going to learn. Very strong, usually within large organic molecules, carbons, hydrogens. Difficult to break, whereas ionic bonds are relatively weak and hydrogen bonds are the weakest. By definition, a hydrogen bond is when two atoms will associate with a hydrogen atom. Hydrogen atom in a polar molecule is attracted to the electronegative atom in the same or another polar molecule. So hydrogen bonds, what I want you to remember, form between polar molecules. And they often will share that hydrogen. They may be short-lived, they're easy to break and reform. An example is when we have DNA, the two strands of DNA are held together with hydrogen bonds. Well, two strands of DNA have to separate from one another and then reform during processes like transcription and replication. So these bonds have to be able to form to hold the strands together and then break. So they're very weak. Here we show some water molecules. Again, the larger kind of orange atom is oxygen. The smaller hydrogen atoms are positively charged. The oxygen is going to be negatively charged. So this oxygen here is attracted to this hydrogen here because they have opposite charges. And you can see that basically in between this oxygen of this molecule and this oxygen of this water molecule, they share that hydrogen. Now the hydrogen is covalently bonded to this oxygen, but it's forming an attraction with this oxygen. Now there's an animation I'm not going to play during the video, but you can find this on Canvas if you would like to see a little more information regarding hydrogen bonds. The next topic is acids, bases, and salts, and I'm going to leave that to the next video lecture, but this is an extremely important topic for us this semester and next semester in A&P2.